let's take a closer look at these protons. We'll see that the protons do not just lie there, aligned parallel or anti-parallel to the magnetic field lines. Instead, they move around in a certain way. This type of movement is called precession. What type of movement is precession? Just imagine a spinning top. When you hit it, it starts to wobble or tumble around. It doesn't, however, fall over. During the precession, the axis of the spinning top circles, forming a cone shape. Protons, in a strong magnetic field, also show this wobbling type of motion, which is called precession. In real life, this is a very fast movement. For reasons we will learn later, it's important to know how fast the protons precess. This speed can be measured as precession frequency. That is, how many times the protons precess per second. This precession frequency is not constant. It depends upon the strength of the magnetic field in which the protons are placed. The stronger the magnetic field, the faster the precession rate, and the higher the precession frequency. This is like a violin string. The stronger the force exerted upon the string, the higher its frequency. It is possible and necessary to precisely calculate this frequency. This is done by using an equation called the Larmor equation. Omega 0 equals gamma B0. Omega 0 is the precession frequency in hertz or megahertz. B0 is the strength of the external magnetic field, which is given in Tesla, T, and gamma is the so-called gyromagnetic ratio. The equation states that the precession frequency becomes higher when the magnetic field strength increases. The exact relationship is determined by the gyromagnetic ratio gamma. This gyromagnetic ratio is different for different materials. For example, the value for protons is 42.5 MHz per Tesla. It can be compared to an exchange rate, which is different for different currencies.